Morning, everybody. Welcome to another Plumbers Tech Talk. This morning we're going to be dealing with open drain inspections. Just so let's kick off and get going. Let's start with the National Building Regulations, the document that governs the building industry. That is basically the be-all and said-all of the whole construction industry. So according to A22, notice in the form required by the local authority shall be given by the owner to such a local authority of a date which shall be at least 2 working days from the date of receipt by it of such a notice, on which, as the case may be, any, let's skip the other ones and we go straight to any drainage installation will be ready for inspection and testing. Then section 3 says no owner shall construct, and we skip through all of that and we get to, and such an owner shall not backfill or enclose a drainage installation until such an installation has been inspected, tested and approved by the local authority, provided that this requirement shall not apply if that inspection had not been carried out by the end of the working day in sub-regulation 2. In other words, the 2 days notice. Let me be the first one to say, guys, that is something that you do as a very, very last resort. If there's any penalties or anything involved, you can consider that. Take photos, have a body of evidence ready. Make sure that you record what you can. You would not want to work in an area and pick up an argument with a building control officer because he skipped an appointment because he was late or because it didn't happen in the 2 days. Maybe 80% of his colleagues have been or from work or whatever reason, you don't know. So if you are going to take that decision that the 2 days is up and we are going to backfill and close, bear in mind that it is going to fall on you. Although you've given the 2 days notice, don't start that fight. Any owner who fails to comply with the regulation shall be guilty of an offense. I can tell you now already, if your client is paying for your services, that owner is not going to take responsibility for that backfilling. It's going to put it back on his appointed contractor. Then we go to P7, which is Part P, the drainage in the National Building Regulations. It says any drain, discharge pipe or ventilating pipe shall be so installed as to be capable of withstanding the test pressures contemplated in PP 26 and 27, which we'll see later, as the case may be, contained in 10.400 Part P. And such a test shall be carried out in the presence of the building control officer or the other officer duly authorized by the local authority. Like I've said before, it might be a senior plumber, it might be someone from infrastructure and engineering, could be anyone. As long as they're duly authorized, you do that test or you're allowed to do that test in front of them. Any equipment, material required for an inspection or any testing contemplated in Part P of these regulations shall be made available by the person installing such a pipe or drain. No person shall put into use any drainage installation before such an installation has been inspected, tested, and passed by the local authority as complying with these regulations. In other words, National Building Regulations, Part P. Any person who contravenes the requirement of sub-regulation 3 shall be guilty of an offense. So we're still busy with the whole offense business as far as the regulation and the act is concerned. Then we get to 10.252 Part 2 that says the drainage installation shall be inspected by the local authority as prescribed in Regulation 822 of the building regs. The drainage installation should be inspected by the owner or his representative, there's Mr. Plumber, as the installation work proceeds. On completion of the installation, before any work is concealed or covered, should be ensured that the pipes and fittings comply with the appropriate provisions of the standard, free of defects. In other words, you've got proper material in the ground. All pipework and fittings are clear of debris and superfluous material or matter. No jointing material projects into any pipe, and that all joints maintain the continuity of the bore. In other words, we've got no rubbers pushing out, we've got no joints cut at weird angles. The pipe work is properly placed, positioned, and secured. Okay, so we've seen the building regulations, we've seen the 10.4 under Part P, we've seen 10.4.5.2 Part 2. Then we move on to the local authorities, and you'll find that 99% of them will tell you exactly the same thing. Ekhuleni, every drainage installation shall be properly cleaned, inspected, and tested in accordance with this section. Every drainage installation subject to the process stipulated in the section shall be cleaned, inspected, and tested under pressure. At least 2 days will be given as a notice. And then it says here, when any drainage installation is being or has been installed, or an alteration or extension of any drainage installation is being or has been carried out, no person shall cover any part of such an installation, alteration, or extension, or cause, permit, or suffer it to be covered until it has been inspected and approved by the council. So guys in Ekhuleni, you've been warned. Mossel Bay, same thing. Maritzburg, same thing. Solplaatjie up in Kimberley, same thing. Nelson Mandela Bay, City of Tshwane. I'd like to pause for a second there. Tshwane has got a very comprehensive bylaw, and it says when a drainage installation has been constructed or drainage work that has been carried out fails to comply with any respect, in any respect with any of the provisions of the building regulations or these bylaws. Take note, the owner must, notwithstanding the fact that he or she may have received approval for the plans for the installation or work in terms of the building regs or previous bylaws, carried out on receiving written notice from the municipality, the repairs, replacements, alterations. So even if your building plan was approved and you've done it according to the plan, the work still needs to comply with the regulations, not the plan. Mfuleni, same thing applies. Mbombela, same thing applies. So we've started at the top and we're now back to where the plumber steps in. Now for the PIRB registered guys, we know that the Industry Board COC is a system and process whereby a licensed plumbing practitioner will self-certify their work, and we go through the list of the certificate of compliance will be issued for most plumbing work, including the geyser one. And I'd like to go down to that red arrow that says the construction, installation, alteration of any above or below ground drainage regardless of the cost. So if you are going to be fiddling with any piece of drainage below or above ground regardless of the cost, you will issue a COC, or you shall issue a COC for the installation that you fiddled on. And take note, when you do issue, the above plumbing work was carried out by me under my supervision, and that it complies in all respects to plumbing regulations, so building regs Part B, laws, national compulsory standards, and local bylaws. So as you saw in the local bylaws, they all require the same thing to happen all the time. So just quick checklist. Always start off, or the official or the auditor or whoever is doing the inspection or the test of the drainage, always start off to see whether there's an approved plan for the work being done. Need to have drainage, even if it's an alteration or an extension, need to have plans for that drainage system. Then we need to confirm that work and the plan relate. In other words, the route of the pipe work on site, gullies, vents, all of that, etc. I'll give you a simple example. This was approved on the building plan, so plumber came along, or the plumber wasn't on site, and these guys decided instead of digging all the way down to the deeper end, they'll cut across and they'll tie in there, which is not 100%, well, it's not incorrect, but unbeknownst to the plumbing contractor, the owner and the architect or the guy doing the plans have already decided that for now they're going to stop here, but they are going to do an extension which would then leave that piece of change of direction under, or that junction under the floor. So if the plan shows it going straight, then that's where it needs to go. Then we continue with the visual inspection. Bedding, pipes lined up straight, filling, backfilling, all of that type of thing. Material. Yeah, you can see there's only one lot of people that work with these green pipes, and that would be Telkom. So if you see a drain laid with a Telkom pipe, then obviously the ID is incorrect to start off with. But yes, you can see, and this thing is above ground and there's a vibratite wall, so that ain't going to be filled over at all. So, excuse me. Sorry about that. Okay, here we can see that manhole, that open end looks like this. 50 mil under the ground. So smallest drain you can have is 110 mil. So short radius bend, you see it's already got wax in that joint there, so it's not watertight. There's no sense in testing any of these drains if you are going to go and waste time testing a drain that needs to be lifted or taken out again. Here you can see as well a manufactured or like a burnt heated up piece of fitting, incorrect material, water standing in the pipe, another telecom cable duct about to receive drainage, gully depth. You can have a look at all of these things while you're walking around on site before you even do the test. Access points, need to check the access points are there as per plan, as per the regulation. There you can see that's within the 450 from the inverter, the bend to the lowest fitting. Two short radius bends, no access at the headed drain. Against the flow, no access to the connection. It just keeps going on and on and on. So all as I'm saying is when we get to site and we have a look at what we see here, none of these drains deserve to be tested, or they'd be wasting your time testing them, because the moment they alter them or cut them or change fittings or remove or shorten something, means you've got to test it again. Then we're looking at the gradient to be checked for the minimum gradient. Easiest way would be, instead of arguing about whether it complies or not, if we take that the minimum gradient on a 110 mil pipe is 1 in 60, and that would mean that your fall would equate, or that ratio would be 0.016, which would give you 17 millimeters per meter. So if you take a 1.2 meter level, make a mark on the 1 meter, and you put that 17 millimeter spacer between the level and the pipe, that bubble should be slap bang in the middle. That would give you 1 in 60 fall. That is your minimum. If your level is out, then obviously you've got one or two options. It's either going to be more fall, which is not a problem, or it's going to be too little, and then you don't even bother with the rest of the testing. You could use that little blocky, or you could actually, some nice gadgets out there. This one here, Omnifall is the brand, or this specific brand, and then that 17 millimeter at 1 in 60 would be the 17 millimeter that you space between the level and your pipe. Tools required, you can see straightforward. You need a mirror and a torch and a screwdriver to get into the fittings. So when you're looking at a bore test, that's pretty much what you'd be looking at. Then if you do happen to see that little oval egg shape, don't even bother. That's what a bore test would look like. If it doesn't look like the barrel of a rifle, you don't even bother looking at it any further, because that means they'd have to lift, fiddle, alter, squeeze around it. So we'd have to make a plan somewhere. Then when we get to the actual air test, manometer, after any drainage installation has been completed and backfilled with water, the drain shall be tested as follows. An air test conducted by pumping air into the drain under a gauge pressure of not less than 0.35 kPa, which is about 35 ml head of water, shall be performed. The drain shall be deemed to have passed if the pressure after 3 minutes is not less than 0.25 kPa. This is from 10.4 under Part B. This is basically the requirement that says this is how you need to comply, or this is what you need to do to have your drain tested and complied with. And then the following test procedure shall be followed when the installation of part of the installation, as the case may be, is tested. So according to 10.252, they go into more detail. You can see 683 or 6.8.3 would be the requirements, and they explain in detail that you need to connect the TPs, you need to shut off. I can tell you I've seen guys use anything from these rubber duck, those pumps that work both directions. I've seen guys use compressors, but just be careful. Compressor, these drain tests are not intended to get pressure in there, it's more volume. So if you're a long piece of pipe and you have someone responsible, you can possibly start off with something like that, or even a compressor that you have in your vehicle for your tires. You need to get the volume in there before you start adding that hand pump, and you add that. So let's just have a look at what the system looks like, or what it's supposed to look like. You'll find that this is going to be your drain plug. It's got the nipple on the end with the adapter or a thread on it, and it's got the hose. So you've got air coming in here through that control valve, and then the air fills up that section of pipe or that length of pipe, whether it be between manholes, between IEs, wherever you want to test the section of pipe. Then the air would go through there, and the same pressure would then be applied on this liquid inside the manometer. So what happens is, when we read a manometer, just start on this end here. In this case here, we've got 1, 2, 3 centimeters and 1, 2, 3 centimeters. You'll find that 0 is level. So the difference between that height and that height gives you 60 millimeters, which would give you 0.6 kPa. So for the drain, we saw that we need a 0.35 kPa, which is a 35 mil head. So you'll see that it's 17 and a bit there and 17 and a bit there. So that gives you the 35 millimeters of head of water. So you leave that, and after 3 minutes, if it does not drop down to 25 millimeters, that drain is deemed to have passed. So on following up on that note, or on those notes, the air test or soundness test should preferably be completed in one operation. However, for large systems, testing in sections is normally necessary. To ensure that there's a satisfactory air seal at the base of the stack, or if only a section of the pipework is to be tested at the lowest plug or bag in the stack, the small quantity of water sufficient to cover the plug or bag can be allowed to enter the system. When we're doing an air test, it's exactly that. We're not going to fill the pipe with, or the whole thing with water, but a clever friend of mine put it to me in the following terminology: water molecules are bigger than air molecules. So that little bit of water that you do let into the bottom end of the stack, or where that plug is, it just helps seal it off, so the air won't go past the water unless you get pressures way bigger than the actual testing pressure. Then defects revealed by the air test can be located with smoke producing machine, or you can introduce smoke under pressure. Leakage can be observed where the smoke escapes. Cartridges, very dangerous when it comes to PVC. We don't want to melt our own drain. And secondly, there's a naphtha has a detrimental effect, particularly on ABS, UPVC, MUPVC. Rubber jointing can also be adversely affected. If you look at UPVC, that is your drainage material. So it tells you up front that if you're going to be burning pellets to have smoke in the pipe, then you're probably going to have hassles. The pipework can be subjected to an internal pressure, and a soap solution can be applied to the pipes and joints, and leakage can then be detected by the formation of bubbles. Then the last option is water can be used to test an installation. The test should not be applied to the whole of the installation, but only to the part of the installation where the defect is most probably located. Before the pipes are filled with water, test plugs should be inserted to seal off the part under test from the rest of the installation. Care should be taken that the static head of at any point in any part of the installation does not exceed 5 meters. The 5 meters being the 50 kPa that the drainage fittings need to be able to withstand. So just to get back to that water thing, years ago we used to test with water. The problem is now, or not the problem, one of the considerations is that if you take a 110 millimeter pipe, 30 meters long, to fill that pipe with water, you almost 300 liters of water gone out of the system, wasted. So you do the same with a 160 mil pipe of 30 meters in length, that's 600 liters of water gone. Now, given the water restrictions and given the water that's available, you can imagine that 650 liters, that's enough water for 10 or 12 people per day, wasted because of something that might or might not be in working order. So have the air test done, water where it's absolutely necessary, but make sure that you get these things tested and that you make sure that everything complies before you backfill. You don't want to do all of what we've just discussed a month after your client moved in, or when there's an issue in getting the certificate signed or getting job signed off. You don't want to get involved with any of that. Get the thing installed properly, check it yourself. It says that the owner and his clients, or the owner and his agents or his appointed agents, shall inspect these drains. Don't call for an inspection if you're not sure that the thing is correct. And then once it's been tested and it's sorted, you can backfill with confidence and walk away and start the next project. If there are any questions, you're more than welcome to just send an email to Articulate it or on the questions tab, and then we'll make sure that we get back to you.